All right, I hope you got the good news that we have concluded the habit. Yeah. You don't know? You're not in the, there's a ME group as well. ME group. How many of you over there? That's great. How many of you over there in that? You're there? I'll send you the link and I'll add you over there. So yes, went very well and it's like beyond expectation, frankly, because we last time we got like two concerns. They are different level of it, and this time we did not get any concern whatsoever. All three departments were like accredited with flying colors. Okay, so we are going to do this. This is the last case, last class of the week, and then you're good to go. The homework 2 is already there, and you know the deadline. All right, great. So this is the third case, and as you see, this time, draw a cam profile operating roller reciprocating follower. So the only difference we have is earlier on we have a knife edge follower aligned, knife edge follower with offset, and this one is with the roller. The information is the cam radius, okay, RC is 25 mm, lift H is 30 mm, and the roller diameter is 15. The roller diameter is 15 mm. So how to do it? So we have a race to, or you want me to read it once? Okay. The cam lift the follower for 120 degrees with simple harmonic motion by a dwell period of 30 degrees, and after that there is a dwell period for 30 degrees. Then the follower lower down during 150 degree of the cam rotation with uniform acceleration and deceleration. So we decided to have only two cases, either the simple harmonic motion or uniform velocity. Only the small thing will change if we follow the acceleration and this. But just to, because the purpose of doing this thing is to understand how the cam is designed, okay? So we just change it to uniform velocity, okay? The two things we decided to do, followed by the dwell period. Okay, so we have 120 degree. Then dwell one is 30 degrees. ID is 150 degrees. And then we need, yeah, it saves some energy, man.
Is it recording?
Yes. All right, so we need to have a displacement diagram. So for the displacement diagram, three, 4, 5, 6, 7, 8, 9, 10. Okay, so there's a very fine difference in doing it, and otherwise you know how to do it. We need to draw. So earlier on we were drawing only the cam radius, RC. Okay. This time, because the roller is involved, so what we'll do is we'll draw the circle And the radius of this circle is RC plus R roller. Okay, so we add them together. In this case, we have how much is the RC? 25 plus how much is the R roller? Yeah, this is a very common mistake. It's your job. Once you get the data, you need to know if it is a diameter, if it is a radius. This is one of the very basic example. All units, all dimensions, you have to check it by yourself. So how much you'll get? Okay. So this is one of the probably the first thing different, and there's few more, but they are very simple. Okay, so the first one is what? Simple harmonic motion. Okay, so for the simple harmonic motion, what you need to do? You need to have a reference of the circle. Okay, so rather than drawing the full circle, we can draw the full circle as well. We just draw the half of the circle and divide it into 6 parts. We can number it 0, 1, 2, 3, 4, 5, 6. From here to here is pi A. 1, 2, 3, 4, 5, 6. It's up to you. You can divide it more. Okay, so we have these angles. We need to draw these. Since we add the roller radius over here, so all we need to do is to draw the roller from here. Okay, so from here to here, it is the roller radius, and then rest of one is the cam radius. So this line, this dotted line, altogether would be equal to 32. Yes. Okay, so this is the roller radius. All the angles we measure from this line. So we have 120 degree, roughly come over here. So this much is our pi A. Then we have a dwell of 30 degree, which is roughly come over here, delta 1. And then we have 150 degree, which will come roughly somewhere over here. So this is pi D, and this one is delta 2. Okay, so this is the first thing we always do it. And then the divisions. One, two, three, 4, 5. This one is your 0 point. 1, 2, 3, 4, 5, and 6. Then what we need to do to extend the line, starting from the center, the 0 point you don't need for extension, starting from the center to the point 1, 2, 3, 4, 5, and the 6 will go like. Since it's a simple harmonic motion, we need to take the reference. 0 is 0. 1, we need to take the reference from here. This is our point 2, the line 2, 3, the line 3, 4, the line 4, 5, to the line 5, and 6 to the line 6. And we need to label it as well, because without labeling, there is a very high chance you get confused, and also the person who is going to review it, they don't know which value you transfer it from where. So 1 prime, 2 prime, 3 prime, 4, 5, and 6 prime. Okay? Once we get these heights, all we need to do is to transfer, because this is the lift of it, h equal to 30. Okay, so 0 to 0, so we have the same point. 1 will go over there, 1 prime, 2 prime, 3, we measure this distance, come over here, 3 prime, 4 prime, 5 prime, 6 prime. Okay, so this part is complete. Next, we have a dual of 30 degrees. So we extend this line, the same line. Okay, and then this is also, we represent the dual over here, dual 1, again the 6 prime, which means that there is no change in the radius. We come over here, 6 prime, and this is also the 6. Okay, any question? No question? Should we move on? Now we have this descent, and again it's because we decided to have this one as given, simple harmonic motion, and this one as a uniform velocity. In uniform velocity, we can have more. It's not necessary, because we don't need to use this semicircle over here, this circle over here. So we can have more number of division. But if you're doing the uniform velocity, make sure that all the gaps between each line should be the same. Because you have one straight line, if the gaps are not same, the things will not be proper. Okay? Let's stick to the 6 for a while and then see how. So this is also 6. Then we have 7, 8, 9, 10, 11, 12. From here to here, we have 5. Since uniform velocity, so the displacement diagram would look like this. And then we have 7 prime, 8 prime, 9 prime, 10, 11, and 12. And 12 prime are the same points. We need to divide this. So once you know the whole procedure, you can do division earlier and then the marking earlier, then the division. It does not matter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is the point 12. Okay? We further need to extend these lines from the center, passing through the point 1, from the center, passing through the point 8, 9, 10, 11, and 12. We don't need to extend it. So 6 is already there. Then we start with the 7. Okay. 7 and 7. 8 with 8. 9, 10, 11 prime, and then this point is the same point as 12 and 12. Okay. This part, if you just ask me to draw, so it will look like this one is basically simple harmonic motion, and this line is uniform velocity. I said it. We are not going to do this case. because we decided to have only two things to do, either simple harmonic motion or uniform velocity. You can do it, but we need to learn new set of skills for that. We're just trying to understand how the cams are designed, that's it. Okay. In the case one, when we reach over here, all we need is to just join the points. Okay. Here we need to do something else. Another step. What is that another step? Since you see we have this RC plus RR, so all the points are compensating the roller radius. So once we got all the points, we have to offset them back so that we get the cam profile. How to do it? Very simple. So you can see this is the roller radius, so which is equal to how much? Radius is basically diameter divided by 2. 15 is the diameter. So 7.5. So this is our first point. Then we come to the 2 prime, and this is our second point. So we open the compass for 7.5. Okay. So on your scale, you probably do not have a 0.5 division. But in some of the scales, the early part of it, they have this 0.5 division, and later on, they do not. You need to do that early part to get this 0.5. 2 prime, 3, so all are here 7.5. Since all points are just offset, so we probably do not need to label them. Okay, once we got all these points, this is the cam profile. You need to draw it more properly. Okay, so this is your okay. Any question? Yes, automatically. When you draw this thing, when we draw the base circle, it was R plus RR, cam radius and the roller radius. It's already involved in it. So we draw this circle over here, which is representing the roller. Now you see this, all the roller is representing like this. Okay, understandable? Any question? No question? All right. I'll do the quick revision, quick revise it, and then you have to draw it, the printout I gave it to you. Okay, this time we have, this one is over case 3, which is with the roller. Okay, so all we need, we need to get the information. The information we have is the cam minimum diameter, minimum radius is 25 mm, lift is 30, and the roller diameter is 50. First thing first, we need to draw this circle, this base circle. Now this time is RC plus RR, which means the roller plus the cam together. Okay. Then we draw the roller over here, and all these angles for phi A, delta 1, phi D, and delta 2. Then we need this displacement diagram. So we know that phi A is simple harmonic motion and phi D is uniform velocity. So we need to have a circle. We take the circle, take the references from there. We divide it into 6 divisions. So we have a 6 division in the displacement circle, 6 division displacement diagram, and 6 division for the reference circle. We take the references, and from there we took the distances, come over here and draw these all points. Okay, on the line which are extended from the center, passing through this division point and furthermore. Understandable? After that, we have a dual. So in the dual, there is no change in the height, there is no change in the radius. So we have 6 over 6 here. After that, we have a descent. Okay, it's 150 degrees. But we decided to have 6 divisions. We divided into 6 divisions. Okay, once we have 6 divisions, divide into 6 divisions, extend the line exactly the same manner. Now this time it's a uniform velocity. Draw the straight line, get the reference point, and we got all these points: 7.8 prime, 9, 10. Once you're done with this, the whole marking and division is completed. The second different thing over here compared to the case 1 is that over there we just draw the cam profile. Here we have to offset these points back in. So once we offset this point, how much to offset? The equivalent to the radius of the roller, whatever the value of the roller. Okay. Each point, because it's the same, just offset of the given point, we don't need to label them. Okay. Once we get all the offset points, draw the profile, and this is how your cam will complete. Understandable? Any question? No question at all? All right. So draw it now. You have like 20 minutes to do it. Sorry? Yeah, if there is no dual, you come to the point 6, and the next point is 7. Yeah, here also. Rather than having another point, you just join this point, and one division left.